Okay, so we have discussed till question number three, I think. Yes. Okay, this is 9701, paper 2 October, November 2024. Okay. So question number 4 कहता है कि bromoalkanes are used in industry although there is increasing concern but about their environmental impact. Okay. Figure 4.1 shows a reaction scheme involving 1,2-dibromoethane. Okay. So they are asking in part A, complete figure 4.2 to show the mechanism for the formation of 1,2-dibromomethane ethane in reaction 1. Include charges, dipoles, lone pairs of electrons, and curly arrows. So this would be partial positive. Okay, this would be partial positive, partial negative. Okay, this pi bond would be attacking on this just like that, and here I would be doing this. Okay, then this would be forming. That's this is of 3 marks. It's too much, but it is very easy question. Then in part B, the enthalpy change of reaction one. Okay, enthalpy change of reaction one is this, or minus 90.0 kilojoules per mole. So the enthalpy change of formation of ethene is 52.2. Calculate the enthalpy change of formation of 1,2-dibromo ethane. Okay. So what's the formula? Delta H of formation is equal to product minus reactant. Okay. It's product minus reactant. Okay. So they have given you the reaction, that is overall answer, that is minus 90. So product is this. Okay. Uh, we have to find out this. So it would be X minus reactant is 52.2. 52.2. So X is equal to minus 90 plus 52.2. It would be giving your correct answer. So what's the answer? Mhm.
Minus 37.8.
Minus 37.8. Okay. Then see this. Then you can see this question. Complete figure 4.1 to draw the structure of compound A and name compound B. So what is A? What do you think? What is A? Of course, this would be a nucleophilic substitution reaction. Okay. Because this is sodium hydroxide aqueous. So of course, bromine would be substituted by OH. So alcohol would be formed. So alcohol would be formed. So I would be writing this. I would be writing this. Okay. Then what they were saying? Name compound B. Yeah, this is B. So what do you think? What is the name of this compound? This is an alkene and also halogen as well. Also halogen as well. So yes. Mhm. First of all, you are supposed to think it, then I would be telling you this. It's very easy. Hmm. Okay, I'm telling you this. Basically, it's it's bromoethene. It's bromoethene. It's bromoethene. It's bromoethene. It has only two carbon atoms. You are not supposed to you're not supposed to fix the positions, because it is already understood that if you have two carbon atoms, so of course bromine would be present at the first carbon atom, and of course the double bond would be on the first carbon. It is understood already. So you're not supposed to mention the position of the functional group. Okay. Draw the structure of one repeat unit of polymer C in the box. Polymer C means that this is your double bonded reactant. Of course, in AS we have only addition polymer. We have only addition polymer. So let me draw the structure of reactant first. Then I would be telling you how you are supposed to do this. This is your bromoethene. This is your bromoethene. So what I told you, just you have to only write down the single covalent bond. This is H, Br, and H, and this is the continuous chain. Okay, as this is the repeat unit. As this is the repeat unit. Okay. In reaction 5, let me see the reaction 5. Okay. This is going to react with an excess of sodium hydroxide, but in ethanol. So rather than the nucleophilic substitution, it is very important to know, rather than nucleophilic substitution reaction, elimination reaction is going to take place. Elimination reaction is going to take place. Okay. So what is the product? Suggest the identity of D. Suggest the identity of D. So let me tell you in this structure. So if you are going to react this with sodium hydroxide and ethanol, Na NaBr and H2O would be formed. Okay, NaBr and H2O would be formed. So of course, the remaining product would be C2H2. Okay, this is removed from this. So of course, C2H2 is remaining. That's your D. That's your D. This is C2H2. Hai. This is C2H2 simple. Compound E is the only isomer of 1,2-dibromoethane. Alkaline hydrolysis of E gives compound F. Okay. Alkaline hydrolysis of E gives compound F. F is the aldehyde. Identify the type of isomerism shown by E and 1,2 dibromo ethane and 1,2 dibromo ethane. So 1,2 dibromo ethane is this. Okay, 1,2 dibromo ethane is this. Okay, so they are saying the isomer of this is this. It is 1,1 dibromo. It is 1,1 dibromo. Okay. So identify the type of course, it's the positional isomerism. It's the it's the positional isomerism. Okay, it's very easy. It's the positional isomerism. Okay. Name the homologous series that F belongs to. Name the homologous series that F belongs to. So you know what is F? F is aldehyde. F is aldehyde. Complete table 4.1 to state what is observed when F reacts with the reagents listed. Aldehyde is going to react with 2,4-dinitrophenylhydrazine. Yes, because this is the test for the presence of carbonyl. Yes, it has a carbonyl group. So you would see red PPT. You would see the red PPT. And of course, Tollens reagent is going to react with aldehyde. So you will see silver mirror formed. Alkaline iodine. So I told you that this is iodoform test, and iodoform test is going to give you for the presence of this group. If you if you think that this group is present, so of course its test would be positive. Okay, this test would be positive for that. So okay. Yep, it has CH3C double bond O. This is CH3C double bond O. Okay. So yes, you will see yellow VPT. You will see yellow precipitate. Okay. Compound F, that is aldehyde, reacts with reagent G to form compound H. Infrared spectrum of H is shown in figure 4.3. Figure 4.3. Okay. Uh, okay. So they are saying H also shows a molecular ion peak at mass to charge ratio 16. Its mass spectrum. Molecular ion peak is going to give you the overall total mass MR of a compound. Use the information in E figure 4.3 and table 4.2 to deduce the structure of H. Explain your answer fully. Explain your answer fully. Okay. So I don't know what is G, and it is reacting with this and it is going to form H. I don't know, but I know the molecular mass of a unknown product, that is 60. So yes, I can just predict something else about after looking this. So let me see the infrared spectrum. So infrared spectrum is going to give you the peak, that is this and this. Yeah, I can say that. I can say that this peak is from 2500 to 2500 to 3000, 31, 32, 33, 34, 30, 30, approximately 3500 centimeter inverse. You can see this is the peak for the carboxyl group. Oh, means that H is your carboxylic acid. And this peak for the carboxylic acid group. Okay, done. And this peak, this peak is from approximately 1600 to 1700, or exact if you are going to look this peak. So this is 15, 16, 17, just like that. In between this, in between this, right? So this is going to show that, like, um, this is for that carbonyl. This is for that carbonyl which is present in carboxylic acid. So it is confirmed that this is your carboxylic acid. This is your carboxylic acid. So initially it is your aldehyde. So means that G is your oxidizing agent. So it's very simple. It's carboxylic acid. That's it. Mhm. Okay. Okay. H is your carboxylic acid. So you are supposed to write over there that the molecular ion peak was at 60. It means that the molecular mass is 60. So of course, let me confirm this. So I can say it has carbon like CH3, then C double bond O, and then OH. So means that it has two carbon atoms and four hydrogen atoms and two oxygen atoms. If you can count this, so you will see that the overall mass is 60, like 12 into 2, then plus 4, then plus 32. It's total 60. Okay, it is confirmed. And then you are supposed to mention the peak of carboxylic acid. You are supposed to write that like 2500 to 3500 centimeter inverse. It's the peak of OH that is present in carboxylic acid. And also this is the peak which is in between like 1600 to 700. This peak is going to show that this is your carbonyl group. Hence the structure for H would be carboxylic acid. So you are supposed to mention each and everything. You're supposed to mention each and everything. So that's all for this paper. That's all for this paper. Okay. Then we would be starting like the next paper. Okay. So